related, but application rate related also. But also understanding the test data will help us to understand if there are certain specifications, whether they're in-house or external specifications that you have to verify submitted products to. Understanding the test data will be a big help to you there. So to understand, test data, whether it's soil amendments or otherwise, and really to develop a long-term successful project, starting with the soil is so important. And we still see major mistakes on projects being made because we're not evaluating the soil appropriately first. So, before we get started with any other things to add to the soil, it is important that we always talk about we test soil sufficiently, which means the bigger the site, the more soil tests you do. We can't forget to do it. We can't forget to do it early in the process. There are times, I know April and I have worked on a couple of projects where we've been brought into projects where there were a whole bunch of assumptions on what was going to be planted on the site, except for the fact that the soil that was available was not really going to be the best soil for those plant pallets. So we have to test the soil, understand it early. It'll help us to determine, can we use the site soil? Can we upgrade or remanufacture the soil on site? Do we have to bring new soil in? But will the plant palette that we're looking to develop work on a long-term basis? And other than that, can we fix the soil with specific amendments? So it's just a reminder that soil testing has to happen early in the design process. It can't be an afterthought. We'll get into the different things that we need to test for, but there are some basic things like soil texture, which is basically the quantity of sand, silt, and clay on a dry weight basis, organic matter, pH, electrical conductivity, which is salt content, and we'll go on from there. There are many different types of labs. Not every region has a university lab. They're all workable. Remember this, try to find a lab that you can work with, that will spend time with you, and that helps to prescribe remedies to the problems that the soil has. Here's a good example. There's lots of different types of labs in the DMV area, but one of the key aspects here, choose a lab that gives good recommendations. There's a pretty nice recommendation page there to the left you can see, and labs that you can pick up the phone and you can call somebody and they'll spend the time talking with you. And finally, certain labs will give you recommendations, right? These recommendation pages, you must make sure, if it doesn't look obvious that the recommendations are for a landscape related project, you call the lab, because there are big soils labs that will give standardized recommendations. Sometimes they're primarily for agricultural applications, and really the recommendations for landscape or turf would not be the same. So in some areas of the country, you want to ask that question when you're working with a lab or a new lab. So here's kind of a look of a standard soil test, and I'm just showing this for background purposes. It is important to know that around the country, if you work with 5 different soils labs, this results page, this analysis page, will look different for every lab. There really is not good continuity. The sad part about that is it makes it more difficult for people to learn how to decipher it. And there often will be extra pages aside from this page, but it is important to focus on the most important information. There's going to be a lot of superfluous information on there, but things I'm pointing at, like pH or electrical conductivity, which is the same as soluble salt content. If everybody can see where I'm pointing at, you see the DS \M. decimeter per meter. People who are in my age bracket, who are probably over 40, 50, or 60, know that that used to use the term millimoles per centimeter. It's the same. The numbers mean the same. Organic matter content, which is always tested on a dry weight basis, right? And then, of course, here's our textural analysis, the amount of sand, silt, and clay. Um, and then there's an outline, or I should say, a determination on this test data sheet of the soil classification. So this is pretty good. It's got some nutrient data to the left and a bunch of nutrient data to the top. I'll get into talking about nutrient data in a minute. And then there's SAR, or sodium absorption ratio. That has to do with are there detrimental salts in the soil? A lot of people don't test for that. But this is a very standardized test data sheet, but they all look different. Over time, the soil amendments available to the landscaping industry have changed pretty dramatically. There's a lot more recycled products. We're not just mining peat moss or getting pine fines. So these new wave recycled soil amendments have different characteristics. They've changed, so the way we've tested them changed. And I'll show you what I mean by that. But as of 2010, I'm an industry liaison to this group called the American Association of Plant Food Control Officials. So this is all the state departments of ag that regulate the sale of fertilizers and soil amendments and lime and stuff like that. But check out the definition that was redeveloped in 2010. When I was back in school in the 80s, we talked about soil amendments improving the soil physically. And today, look at this 2010 definition. Soil amendments are intended to improve the physical, chemical, biochemical, biological, or other characteristics of soil. So the understanding of what these soil amendments, because newer, different products have come onto the market, like Bloom, which is biosolids based, and a bunch of different compost products, they bring with them nutrients, they bring with them microbes and other things. So the marketplace has changed when it comes to available products, whereas these recycled products kind of dominate the market now. Remember that there are different types of soil amendments. There are organic matter-based soil amendments, and then there are mineral-based soil amendments, because soil amendments could be expanded clay or shale that you put in a rooftop mix, or a bioretention soil, or even sand. But these mineral component soil amendments are much more expensive. They're heavier, and we tend to not see them in typical landscapes, but in the higher cost specialized areas of the landscape. Most of the soil amendments we use in landscaping to fix the soil are organic matter based, right? And the best ones are always stabilized organic matter. The landscape industry back in the day used to get manure, raw manure. We don't do that anymore. It's too difficult to work with. We sometimes use the term hot. It's high in salts or ammonia. We focus on stabilized organic matter sources, which we understand what they do in the soil. The organic matter-based soil amendments have a great benefit of fixing the soil physically, chemically, and biologically, and they're much less expensive. The only negative is that they degrade over time, and you add more, or you protect the organic matter that's in the soil. One of the newer organic matter materials available in the DMV is this Bloom product, which is produced through anaerobic digestion and then thermal hydrolysis. And it's basically taking a dewatered biosolids material and pressurizing it and heating it so it's weed free. And they make a pretty interesting soil amendment and actually a series of blended products out of this material. And we'll show you some more information on the different types of soil amendments. But these new wave soil amendments like Bloom and to some degree compost, They do a lot more for the soil. Again, they supply organic matter, nutrients, even though they don't always claim the nutrients because that moves them into the fertilizer realm. Beneficial soil microbes, and there are certain products like Bloom that actually have some interesting drought resistance characteristics in them. So the fact that we have new benefits or more benefits to these soil amendments is one of the reasons why we test them a little bit differently than we used to. Thanks to the growth of the composting industry throughout the US, there is a standardized, much better standardized testing labs out there to test soil amendments. And the beauty of standardizing some of these test packages, it's easier to teach people how to understand them, but it reduces market confusion. If you test for the same characteristics and you use the same units of measure to report it, the same test methods in the labs, we can now, for landscape architects, for engineers who could be doing work all throughout the United States, you could look at products and compare them from 5 states away and have a better understanding of what they are. So what are the things we're typically testing for today when it comes to soil amendments? Well, things like salts and pH, and certainly moisture content, organic matter content, and here's the whole list of them. And I'll talk about a few of them in detail, but I won't go too deep into it because I do have a handout that I can forward to people that explains a lot more why we test for certain specific parameters. But the one thing I will tell you here is I have a little arrow here saying, don't get so hung up on the nutrients. And what I mean by that is a lot of landscape architects will have soil amendment specifications that have nutrient requirements or soil specs that have nutrient requirements. And I personally, as somebody who's studied soils and plants in school, I think that's overkill. Here's what I mean by that. You can easily modify the amount of nutrients in the landscape by adding a chemical or organic fertilizer. So I don't want people to pass up on high quality soils or soil amendments just because it doesn't meet a certain nutrient, because you can easily fix that. Some of the other parameters are much more important. Okay. The key thing with nutrients is make sure that you don't have some crazy volume of some micronutrient that is known for causing deleterious effects to plants. But I show this slide just as to mention it. This is not what typically happens. It's having a bunch of trace elements that bind other ones and being concerned about that. It's not. It's a complicated subject, number one, but the lab testing and the lab should help you identify any of that. And it is somewhat rare. Okay, so just don't want you to be caught up in that. So, looking at things a little bit closer, I want people to concentrate on the young woman here. She looks much more studious than the person to the right. He looks a little overwhelmed. But let's look at some of the test data sheets from soil amendments, okay? And this is just for comparative purposes to just so you get involved here. So the sheet to the left here is a test data sheet. It's a compost technical data sheet, it's called. And this is a standardized compost label sheet that's used by the National Testing Program. So there's 600 products around the country. The sheet to the right of it is just a backup summary sheet. And I just want to show you that because all the labs that all the labs that are in this testing program, they all use this uniform test data sheet. So you could get data from 3 different facilities, 3 different composters, and you could have the data looking the same. Notice the arrow, the units of measure will be the same. um, on the sheet, so there's no funny business on comparing and use results. But the interesting aspect is each lab, the backup paperwork may look a little differently. So I just show this one to the right because later on I'm going to go through these different quadrants and talk you through some of the information. And it's easier to work with this sheet because it's in quadrants like this, okay? But this technical data sheet is something that most of the good compost out there you can get it look at. And once you get familiar with looking at this sheet, which we'll do, you'll feel comfortable comparing it. And a lot of other products like Bloom will use a similar test package because it's easy to understand the data in comparison. Here's some of those backup sheets. One done by a lab in Pennsylvania, Penn State, one done by one in California. You can see these backup sheets look a little different. Everybody's going to have their own favorite, but this front sheet's going to be the same. All right. Take a look at this. This is a sheet. These are sheets from Bloom. Remember that there are different labs that have different focuses. So the people at Blue Drop, here's agronomic and horticultural lab to the left, and then here's an environmental lab. There's specific environmental testing they have to do to market their product, and that testing is done through an environmental lab. So I'm a firm believer that I don't want my nutrient data and agricultural data coming from an environmental lab, and I don't want my heavy metal data or from an ag lab. I would rather have that from an environmental lab because they specialize in the testing of these materials. But some facilities have to test for different numbers of things. Okay. And here's a couple different lab packages that the people at Blue Drop use for the Bloom material. One is just more extensive than the other, adding in additional tests. That's all this really is, and they're using different ones to save a few dollars over an annual quality control budget. So briefly, let's talk about what we test for and why. Again, I have a handout that I can share on this, so we'll move through it quickly because if not, people will be passing out, okay? But we test for pH. Why do we test for pH? Well, because we know plants have a specific soil pH range that they like to live in. It doesn't mean they can't live outside of the pH range, but they live more efficiently, and they can extract nutrients more efficiently from the soil by living in the pH of soil they like. Similarly, electrical conductivity or salt content. Most plants have a maximum salt content that they can handle before they start getting injured. So we want to know about the electrical conductivity of the soil and, of course, of what we're adding to the soil. And both of these tests are critical for both soil and for soil amendments. I want to show you something here interesting because I started doing research with the Bloom product from Blue Drop and DC Water, and I'm pointing right over here. Here's an 80% soil mix, 20% mix of Bloom. And here's 80% soil, 20% Bloom's Woody Blend, which is a mixture of Bloom and bark, tree bark. And then there's compost, 20% compost. And interestingly, people would say, look at this high pH of Bloom. Now, the interesting thing about that is the pH of this product, if you look, blended into the soil, after only 1 week, and then you start going down from here, notice that the pH of the soil, the original soil, is 6.9. We add the Bloom, the pH goes up, and then it drops back down and it stabilizes not far off. There's 6.9 to 6, and if you look at the Woody Blend, it's 6.9 to 6.7. So basically what this means is the Bloom products do not have a strong buffering capacity. They don't, even though it looks like their pH is a little high, they don't strongly buffer the soil. Where if you look at the compost down here, here's your soil at 6.9, and here's your compost. Oh, I'm sorry, we added, yeah, there's your compost at 7.0, and then we blended it in, and there's a slight rise in the pH, right? So all that really means is this compost has more of a buffering capacity than the bloom does. Buffering and pH change are related to the volume added to the soil. So you always have to remember that. But the point being is, with some of this information, and even you can notice that the salt content of the bloom products drops dramatically because it's affected by the ammonia content. So it's really interesting because certain soil amendments, it's helpful when you have the people who supply it can provide technical input because some of them have a stronger modification or change to the soil than other ones do. But I found this to be fascinating to look at these materials over time, which is the key. We test for nutrient content of these different materials just so we can consider how much fertility we need to add. We test for organic matter content because we're adding them primarily for organic matter content. Um, Moisture content we test for because of the ability to handle the material. If it's too wet, it gets clumpy and heavy to ship. What is fascinating is a couple tests that are done for soil amendments called stability and maturity. And these are newer tests, under 20 to 25 years old. Um, and they were developed for compost. They're used for different soil amendments, organic soil amendments. Stability is actually a test where you put the organic matter in a closed vial and you actually measure the CO2 that's being expelled by the microbes. So the microbes are trying to break down the organic matter. The more CO2 they generate, the younger the product is. The least amount of CO2 generated, which means the product is really well degraded, means it's less available food for the microbes, means that they respire less CO2. So stability is like a golf score. You want a low number. And if you look at these pictures, this is tomato research I was involved with down at the University of Florida. On the right, we had a nice stable compost which releases nutrients from the organic matter. And over to the left, this was unstable compost with a really high carbon content. And what happens when you put that in the soil? The microbes are better at getting the nitrogen from the soil and the compost than the plant is. So the microbes take the nitrogen to try to stabilize the carbon and steal it from the plants. Pretty cool stuff, right? And then maturity test is a growth screening test where we take one part of the soil amendment, typically compost and 2 parts vermiculite, and we blend it up and we plant seeds and we compare the growth of the cucumber seeds to the blend versus pure vermiculite. And we measure plant growth. And really what we're looking for there is, are there any substances that are harmful to the plants in the soil amendment that we're adding? And it picks up things like volatile fatty acids and salts and ammonia and things like that. But it's a pretty good standardized test, just a do no harm type of test. It takes about 3 weeks to run the growth germination, the germination and elongation test. But these are quite new tests. And then we test for things like pathogens and heavy metals to make sure the products are safe, which this is typically not a problem. And it is important to note also, when you get test data, remember that sometimes some labs are better than other labs in providing interpretation data. It is good that when you get this type of data, if you have any confusion with it, call the lab. I work with these labs, and sometimes all of this interpretation data is automated, and sometimes it conflicts and it causes a lot of chaos and confusion. So it's great to work with labs that have good. Oops, sorry about that. Who have good interpretation sheets and are willing to explain it to you. Note there's a lot of other things that you can test for, okay? But word to the wise, don't overdo it. We have people who test for a lot of extraneous things. Unless there's a really good reason, there's a good understanding of what the data actually means, it's better not tested for. When you get into more complicated systems, sure, there's other things that you may want to add, but I just think it's easy to overdo it sometimes, and it's better not to. Okay. So now we're going to take a little bit of a deeper dive and looking at some of the sheets, and I'll talk you through some of the stuff, and I'll make this presentation and some blow-ups of some of the pages available to you all, because you could use them as cheat sheets as you're evaluating products that come in during the submittal. But let's just go back to the beginning here. We're going to use one of these summary sheets and look at it by quadrant. And I will say this, that Phil or April, if somebody puts in a question in chat that looks really, really important as I'm talking, stop me. And if not, we'll take the questions at the end. But if there's something and I'm blowing it and I'm not explaining it, jump in and
Yeah,
have me
we've got a
go.
couple questions, but I don't think anything they can't wait.
Okay, great. Thank you for that. Okay, so here's a top quadrant looking at things primarily nutrients, and the biggest things I want you to jump out at is that unlike for like a chemical fertilizer, when we look at soil amendments, um, there are different nutrients, but there's different forms of those nutrients. So, for instance, here's here's your nitrogen content, but this test data also shows nitrogen in different forms. So organic nitrogen, what I'm pointing out right now, is what we would typically call slow release nitrogen. And that slow release nitrogen will be released from the compost over really a 2 or 3 year period. Okay, that will slowly meter out. The ammonia based nitrogen, it can sometimes plume off, but if you take this material and incorporate it right into the soil, that ammonia will bind up into the soil and convert to nitrate and then organic nitrogen. But what we like to see here, you see this total nitrogen content of 1.1, and then you see an organic nitrogen content of 1.0. I like to see 90% or more of all the nitrogen in organic form. So that means the majority of what you got is going to be in slow release form. Um, Notice that below that you have phosphorus P2O5, that's the way it's reported. By the way, I'm pointing at this column here that says as received. You always look at fertility on an as is basis. Fertilizer doesn't have any water. Soil amendments has moisture in it, so the nutrient content is diluted by the moisture. Okay, so but notice there's 1.7% P2O5. That's a nice amount of phosphorus. However, these organic forms of phosphorus, really they're chemical forms, but they're attached very tightly onto organic matter. Only maybe 10 or 20% of that will be available the first year. It's very, very slow to release into the soil, which is good because actually phosphorus is one of those nutrients that if it was really, really mobile is not good for getting into water. That's what causes the problem in the Chesapeake. But most phosphorus is really not a problem or coming from organic matter when it's incorporated, especially into clay and silt soils. It's really bound very, very tightly. The only time it really moves is when it's in sandy soil. And then you have potash or P2O5 and calcium. What else do I want to mention? Oh, the potassium. Most of that is available the first year. It's a very good overwintering fertilizer when you apply these materials in the fall. I think good things happen to turf. And then one of the things we're starting to look at now, so I'm 40 years in this industry, and we're now, if people are familiar with specifying compost, there are more compost being produced with food waste in them. And we're starting to see the sodium and chloride content of some of the products go up. These numbers right here are quite low, but table salt, that sodium and chloride are very bad salts for plants. They have a very high burn capacity. So that's something the compost industry is monitoring on an ongoing basis now. It's not, this test data is for the Bloom Woody blend. It has very, very low sodium and chloride. Here you go. Here's moisture content. Um, pH 8.3. We usually limit these materials. We look at most of these materials are between 6.5 and 8.5. Um, Conductivity, which is salt content. We kind of want that either below 5 or below 10, depending on the plants we're growing. Organic matter content, that is typically evaluated on a dry weight basis. There's over 60%. That's a very, very good number. When you buy a compost, you want it to be 40 or 50%. This Bloom product is a little bit higher. That's nice. That's a good number. Um, Remember, bulk density wise, so this is 48 pounds per cubic yards. If your product is 37 pounds per cubic foot, that means you get 2 cubic yards per ton of product. And that's kind of a relevant thing to know when you start shipping big giant truckloads of material. Um, Also, compost products, once they get above maybe 50 or 55% moisture content, they can get quite clumpy. So you want the compost to be below 50, 55 percent moisture content. This product doesn't clump up the same way when it's over 60. Okay. Also, remember this when you look at ash content on some of these sheets, it's not the same thing as ash content that they use in grass seed evaluation. Ash is nothing more than sand, silt, and clay. It's really dirt content in the media. Okay. So, and if you add that content up with organic matter content, it equals 100%. Um, this is heavy metal content. I'm not going to talk much about it. And the main reason is take a look at the EPA standards for compost and biosolids over to the right. Almost every one of these products I've ever seen is an order of magnitude lower than the national limits, literally 10 times lower. So heavy metals and things like that are not typically a problem when it comes to these materials. You can remember one interesting thing. If you see 10,000 parts per million, 10,000 parts per million equals 1%. All right, just to keep in mind. Uh, Even though a lot of these materials have products in them or with that would be considered as heavy metals, iron, manganese, molybdenum, nickel. These are all plant and human nutrients, right? Things like arsenic and cadmium and lead, they're the bad ones, right? But you can see how low the content of these problematic heavy metals are. They're very, very low. Okay. And they're typically bound very well onto the organic matter. When it comes to the stability and maturity, you're typically looking at the CO2 evolution based on organic matter per day, and we want a maximum number of 4 or 5. Okay, so this product's at 4.7, right at the limit. The maturity testing, remember that little growth trial we showed a picture of? You want that at 80% or above for both seed emergence and for seedling vigor. So this works out well here. And then a part of the testing, they also do a screening and they capture physical contaminants. You can see this material is totally void of physical contamination, which is fabulous. The other negative aspect of food waste composting is there's a lot of packaging waste that can get in it, and we're starting to see some of these products get a little dirtier, which is not very good. And then the other thing you'll see on the test data sheet is a screen is a particle distribution analysis. And this information is only really relevant for when you start specifying compost for use in erosion control and specific stormwater applications where particle sizes or even mulch. They even make composted mulches that having a coarse fraction is important, but these are the screens that we use in the testing package, and for instance, the 6.3% over here represents the fraction that is it oops, I'm sorry. That is it's over 6.3 millimeters, but under 9.5, and it goes down. But the important concept here is typically this 9.5 millimeters. That's about a 3/8 inch screening. You're going to typically see 90% or more, 95% or more below that number for a soil amendment based compost or a soil amendment in most cases. Okay. I do want to mention when we talk about specifications and looking at specifications can be modified. So the better you get at understanding the soil data and the soil amendment data, you can help clients. Here's a good example where I was involved in a project, this Frederick Douglass Bridge project, where compost was specified, compost was not available, it was sold out. We did soil testing and realized instead of bringing large volumes of soil onto the project, here's the compost spec, by the way, down here. We could actually bring sand and bloom, this THP product on there, and actually manufacture a soil on the site to create a soil that met the characteristics of the finished soil that they wanted to bring in. And this is an important concept because this is often the case. It can be half the cost on these big projects to manufacture the soil on site. But the issue is it just takes a little bit of technical know-how. So if landscape architects don't have that know-how in-house, they have to get assistance from outside. But a key aspect here is if you have to swap materials out, they obviously have to be comparable in nature. And here's the project as we finished it off, but we were just able to actually lower the cost of the project and keep the project rolling because they couldn't get compost. We brought in a different product. We were able to show that we could make as good of a soil less expensive. So finishing up here, I want to show you a few more comparisons as if you were looking at two different products that were submitted to you, okay? So here is a biosolids-based product to the left. I will say that it's not the best quality product, okay? And it's being compared to a yard trimmings content on the right. So what I'm showing you here in these arrows is take a look at the ammonia content, okay? So on the right, compost, we typically want below 500 parts per million of ammonia on an as-is basis. The bloom products, I like to see under 1,000, but look at this number over here on this biosolids product. It's up to 58, 100. That's about 0.5% of that nitrogen is in ammonia forms. and look how that affects the conductivity. You see me circling the salt content? Ammonia is a fake salt. It's a transitional salt. It's not a true salt. And when there's a high ammonia in these materials, it drives up the salt content. But once it stabilizes in the soil or converts, that salt content goes down. And sometimes it affects the pH, just like it did in that bloom data I was showing you. Notice over here too, the two different composts. The one on the left is 30 pounds per cubic foot versus the yard trimmings compost. That one is just heavier. It just means less material can fit in a truck. The first thing I look at when I see compost that's a little heavier is I look at the moisture content to see if the moisture is driving up moisture content or soil mixed into the compost by accident drives up its weight. And take a look at the ash content over here of 71%, which means the organic matter content is less, but it means that is what is driving up the weight of this compost. Notice the moisture content's over only 26%. Composts are typically 40 to 50% moisture. So just by looking at the data, we know that there's a lot of soil blended in to that by accident, which means they composted on a dirt pad. Okay, so we're just looking at this data, understanding what it means, right? Here's another product. Okay, so here's the woody blend compared to a yard compost, right? A different yard waste compost. So the woody blend again has higher ammonia content, a little bit higher nitrogen content. That should not be a problematic number. The ammonia number for the yard trimmings compost is quite good. Comparing it, take a look at this. These two products are produced very differently, but their salt content is very similar, 3.4 to 2.6, both really good numbers. And even their organic matter content, 58% versus 61, are also quite similar. So this is kind of an interesting one in that these are two products that are made very differently, but a lot of their characteristics are the same. And this Woody Blend product was actually designed to be a one-to-one replacement for yard trimmings compost. And here is and in the foreseeable future, maybe April can tell us about that in a second. They're going to be taking their bloom product and curing it, which is a way of aerating it and windrowing it and further stabilizing it. And we did a bunch of research on this years ago. And take a look at this fresh bloom product is typically used for these large soil blending and land projects, and it's used by farmers because it's a little wet to handle by a landscaper. But look what happens when we age it or we cure it. Take a look at the ammonia content. There's your 1100, and it goes down to 250. So it converts to slow release nitrogen, which is very good. And then you look at the maturity numbers, they're better, and the stability numbers are better, just like the science shows us. When we take organic matter, we give it a little bit more time to stabilize, you get additional benefits from the material. The organic matter content overall really doesn't change that much, but this cured product will have a lot more applications for finicky plants than would the fresh product. So that'll be a new product coming along. And they also produce a product which contains bark and one that contains bark and sand for specific applications. And if you compare these two products, what jumps out is number one is nutrient content is going to be less because you're diluting the high nutrient ingredient with either bark or sand. But take a look at well, the pH is actually quite similar. It's the bulk density is quite high, 61 pounds per cubic foot because there's sand added in it, right? That makes total sense. And notice if you compare the organic matter content, if you have a high sand content, your organic matter content is going, where is it? Here it is. It's going to be very diluted. You see the number right there, only 16%. Whereas the woody blend, it's there's a bark and biosolids or bark and bloom mix. Bark is 90% organic matter. So that mix is going to be increased in organic matter content, 61%, right? So I'm just showing some of these comparative things. It is interesting. Sometimes you look at the data and the data makes total sense. Sometimes you sit back and you have to try to figure out what am I looking at. But this is kind of like just I hope it delves you into it, didn't make anybody's head explode. Um, but understanding the test data for soil amendments is a real big deal. Obviously, it will help you to design your projects better, to pick and choose projects that will positively influence the soil, and ones that will help improve the soil to help the plants grow better on a long-term basis. Remember, whenever possible, try to find a good soil testing lab, one that will spend time with you on the phone and talk to you about some of the information and questions you have. And just remember, don't get stressed out about this stuff. It's a learning curve, and I will put together a package of background information that I will send off to Chris that she can distribute to anybody who wants it, including these presentations. And at that point, I will stop talking and stop sharing the screen, and I will answer any questions I can. And thank you very much.
And thanks, Ron. There are some questions in the chat. Um,
Okay.
Starting with a few people were interested in that handout. So I don't know if you want to send the handout you were talking about to Chris as well, and she could.
Absolutely. I'll send the presentation, some blow up pages, and these handouts. No problem.
Okay. And then April, I don't know if you want to jump in, but I can just go through the questions. The first question was, can you talk about soil compaction and your recommendations for that? Are they physical treatments and or organic amendments? Thanks.
Yeah, that's a great question. I mean, one of the biggest problems we have in the DMV area, and I live in North Carolina, I grew up in Pennsylvania, is once you start getting over 65 to 70% combined silt and clay, you're going to have compaction problems. And it's the biggest long-term problem we have on project sites when we have grass that's stepped on and stamped out. Also, we find that now with climate change, compaction is even a bigger problem because we lose the soil's ability to help us with stormwater management if it's too compacted. So, yes, the addition of that's why I tell people I aim at 5% organic matter in a landscape soil. For turf, you can even be higher in garden and landscape beds, but I'd like to see 5% um, in especially in soils that are heavy in clay and silt. And it's really just to slow down compaction. It's exactly for that reason. Um, Once we have compaction, I mean, we need to be doing core aerification wherever possible in turf. And there is some deep tine aerifiers that we should be using more and more that actually will put like not a hollow, but a solid tine a foot into the ground, and it does a little shimmy, and it cracks the soil profile a foot deep. I could also send some information on that in this package I sent back. I'd love to see these units being more on project sites to handle compaction, but aerification is the first line of defense and specifying soil with 5% organic matter in it, I think.
Carrie, you asked that question. Did you want to follow up with anything? I'm trying to unmute you.
Wait, can you hear me?
Yeah.
Yep.
Yeah.
No, that was great. That was really
Okay.
helpful. I guess one follow-up would be, do you ever design like a document that, like, for example, I work for Montgomery Parks, like a guidance document for a firm or organization to help them with this kind of stuff, like kind of a cheat sheet. That's just kind of would be helpful for me. But this has been great, so thanks, Ron.
Yeah, and some of the stuff I send back, you'll see for if you're talking about evaluating the test data, I will put some cheat sheets in there.
Great.
Yep.
Hey, we
Thank
had
you.
the next question was, is it critical to ask for pH buffer in the test analysis?
Um, it depends on what soil scientist you talk to. If if um um if the pH of the soil is in a recommended range for the plants or for the turf, I wouldn't worry about it. But buffer pH is a test that helps you determine when you add stuff to the soil, how much will the pH change? The beautiful thing about adding organic matter to the soil, whether it's compost is especially good at this. A bunch of these products have very good buffering capacity. So once you add them to the soil, you give 2 or 3 weeks for chemical reactions to occur. You'll see this pH of the blended soil, and that buffer, that pH is gonna stay where it is for quite a while. So in general, organic matter is really good at buffering soil pH. And the other thing that's really, really important about adding material to the soils is if you're only adding 10 or 20% by volume to a soil, you're only going to get so much buffering from it. The materials with the dominant volume, which is still going to be the normal soil, is going to have the highest effect on the pH, no matter what you do, unless we start adding lime and sulfur. And lime is certainly easier than sulfur is, chemistry wise. So I don't know if I confused it more or I explained it more.
Yeah, I think the person who asked that question couldn't stay. So,
Okay.
next question: do you recommend manufactured soils to be mixed in with site soils for plant adaptation?
Okay. So what I'm really saying there is, are they asking that question? Or are they
Yeah.
asking for clarity?
Well, it says, do you recommend? I can.
Right. What I no. Okay. So on some of these project sites where these big land projects, there's often a desire to scrape soil away and bring new soil back. And the volume of truckloads of material that are moved are outrageous. And the cost is really, really expensive. So what we find is lots of times, if we do good soil testing, we find out that that base soil is often very, very good. It may be missing a component, like on the couple of these Maryland projects we did on the roadside. We realized if we could bump the sand content up a bit, and of course the organic matter content, we wouldn't have to transport a lot of material off. We could remanufacture the material right on the ground. So that's what I was talking about there. Um, that you can manufacture the soil on site, um, and probably save about 50% of the cost of a large land project by doing it that way. Some people, just so you know, just in case I'm interpreting the question the wrong way, some people bring new soil in, and then they will incorporate it into the subsoil below. I'm not the greatest fan of that. I would rather take the subsoil it with some type of incorporation unit, a disc or something, put the compost, or I'm sorry, the blended soil on top. It will slowly move and migrate into that soil as long as we decompact it first. And I'm okay doing it that way.
Okay. Yeah, that person had to leave as well, I think so. Next
Then
is
the question must not have been that important to them.
next question is, could you share one or more examples of a good baseline soil specification that can be adapted?
Um, I could try to dig a couple up.
Okay.
If and do that, sure.
Yeah, if you want to just send them to Chris, she could. If it was, PDF or whatever, you should just send them out that way.
Yeah, actually, sure.
Okay.
Actually, April and I were just working on one for one of the local DOTs to look at modifying. They were asking input for modification, so maybe something like that could be shared.
Okay. Let's see the next question. Lots of thank you. So good job, Ray.
Yeah, Carla had a question there.
Yeah. Is there still a place for adding pine fines to improve soil?
um, Pine fines is quite a interesting soil amendment. I have to say, as a horticulturist who was trained in Maryland and in Pennsylvania, when I moved to North Carolina and I saw these 3 cubic foot bags and it just said soil amendment across it, and then you looked at the clear bag and it was ground up pine bark, I was baffled. This was back in 1991. And that is a lot of what was used in the southern states before the growth of the composting industry and the recycled material industry. The material is fascinating. It can lower soil pH if you need to do it. I would rather see that used than peat moss. And things like pine bark blended with compost or with bloom, all of which have disease suppressive characteristics, can make a really cool media. So down here where I live, we have super heavy soils, so we'll sometimes add compost, sometimes add a biosolids product, kind of like a bloom, but we'll also add some pine fines because they typically have a slightly coarser size and they're slow to break down. They're high in lignin, so they're slow to break down, but they don't pull a lot of nitrogen from the soil. So it is an interesting product. In your neck of the woods in the DMV, I would use it mixed with one of the recycled materials, especially when you want to moderate pH, keep pH down and not from going up. I would use that instead of peat moss.
Okay. That was the last question. Carla, I was trying to unmute you if you had any follow-up to that. Oh,
And
Looks
also, if
like
you have
Douglas
a
just had a question that popped in too.
yeah, I just saw that. With regard to soils to grow our food, how do these amendments impact the microbiome of gardens?
oh, the microbiome. How do we even define that term? Um, One of the things that we know, we're still learning a lot about microbes. By the way, I finished a fascinating project that was funded by DC Water and Blue Drop, and we actually did soil blends with compost, with the Bloom products blended in soil, and we used DNA sequencing to track the different microbes that were living and changing in the soil mixes. So this is an ongoing science that we're learning about, and we're and the people who produce Bloom are digging into some of this. Is pretty cool research. Um, the key aspect that I would say is one of the biggest problems we have across the U.S. today is erosion and loss of organic matter. By simply adding these stabilized organic matter forms to the soil, two things we see happen immediately. We have higher populations of plant beneficial microbes, number one. And typically, when we add these organic matter based soil amendments, we see a greater diversity of different types of living creatures. Okay. And some of the soil scientists who are trying to define, are there tests we can do to define soil health, which is not a simple question. We don't have that answer today. They will say that the key aspect of soil health is high microbial population and high microbial diversity. So with a lot of these materials, even though some of them are made of quote unquote societal waste, they're not as dirty as they once were. These materials, by adding stabilized organic matter, are doing a great benefit to improving soil health. And a lot of us in horticulture believe when you start seeing these organic matter rich soils, we call them healthy soils, fine, we see better plant growth. We see more diverse plant growth. We see plants being able to be grown not in their typical pH ranges. We see plants that were injured by environmental conditions bouncing back. So it's a hard answer to give, but what we're finding is, there's a reason why organic matter accumulated on the soil surface over the years, and it's there to help feed us. It's also used um, as a way for the environment to deal with contamination, breaking it down or binding it. So the mere presence and use of these materials is such a big benefit. And when we start talking about it, if we go and take the environmental path, people start rolling their eyes. But there are so many practical as well as environmental benefits to dealing with these materials and starting the project off with a better soil. I really believe this is the big education push moving forward. And the landscape architecture world is going to be part of it. You'll be educating your clients, spend a little bit more money upfront, fix the soil, your long-term maintenance practices, your long-term damage because of the erosion and stormwater will go down. Just trust me. And I think that this is where we're going. And by the way, I did work on a manual with a PhD named Dr. Sally Brown that's now available through the ASLA. And it's about fixing soils and healthy soils. And that is available through the ASLA somehow. I don't know how, but it has to do with your climate change initiative. Very long-winded answer. I apologize. It's a gift.
I guess the last comment was that the human race is considered organic, yet has much that is harmful to our gut microbiome. So, and I know we're way over time, so I don't know how much time you want to devote.
If that person would like to reach out to me on a Friday night when we both have a brown liquid in our hand, I'd be happy to talk about it some more.
Okay. Yeah, and just a bunch of compliments, Ron and April. So great, well-received presentation. So thanks
Thank you.
for
I'll
time.
put together a package. I'll send it over to April and she'll forward it to Chris and it can be all distributed out.
That
Okay.
sounds great. Well, thanks everybody for attending, and thanks again, Ron, for a great presentation.
Yep. Thank you all.
Everyone. Thank you,
Thanks,
Ron.
April. Have fun out there in Colorado.
Thanks. Have a good one.
See you
Alrighty.
guys.
Bye-bye.